Goeiedag iedereen. Dus ja, mijn talk is getitled Let's Reimagine Ergonomics. I was asked to talk in English, so here we go. So it's about the Flanders Make AugmentX Research Center or Laboratory. So what are we talking about? Well, basically with the Industry 5.0, there are a lot of developments that are very human-centric. And so when we looked at the human-centric challenges in the industry, we immediately think about fallout. And this can be due to overstressing a person, basically. So there is, of course, mental stress, but we didn't focus on that. We mostly focused on more the physical stress. And then we are thinking about excessive loading, repetitive loading, and aging workforce. So what do we do as humans? Well, we monitor and we adapt our environment to provide better physical and mental support. Again, we are mostly going to focus on the physical support in this talk. So this is an example. It's a real-life example. This is a farmer, and before he took over the business of his parents, and his parents were two. They had 100 cows. He's alone. He has 200 cows. He invested a lot in a lot of things to make his work ergonomic, but still you see that he's now using also an exoskeleton. And for him, this is a perfect thing. You know, it doesn't make you Superman, the exoskeleton, but it provides you just enough support to do this task, and it's far-reaching, and it's sometimes above your head, and it's repetitive, and you do this 30 years, and your shoulders are completely destroyed. So this is the type of work that I'm looking at. What we see in these new technologies, we see that they're collaborative robots, they're exoskeletons, but we see that sometimes these technologies become very close to the human. There is a very intimate contact. And if you want to start to estimate the performance of these things, then you need to basically look into ergonomics, but you need a bit more than what was the case up until now. So the case up until now is that we looked at the people's posture. How are you standing? If you are standing like this, for half an hour, it's not so good. But if you are standing like this for 5 minutes with 50 kilograms around your neck, then obviously it's probably worse, right? So it's very important that we include these forces. Another thing that's difficult also, that's very challenging, is that we have to define performance. There are a lot of standards around. This is a bad posture if you hold it on like this the whole day. But there are not so many standards around this during 5 minutes with this weight. So the standards also have to evolve. So basically what we need a more accurate way to measure the load of work on site. We need to have a place where we can test these new technologies, discover them without having to pay too much money to bring them into our workplace. We also need some unbiased knowledge. If you go and talk to exoskeleton providers, every single one of them will explain to you why they are the best, and then the day after you go and visit another one, and again you will feel like, no, the guy from yesterday, he was wrong, this one is the best. So it's very difficult to make up your mind if you are interested in this technology, and as I said, also standardization. So what is AugmentX? I think AugmentX is a new approach to look at work. We are able to measure the movement of persons, and we are able to measure to a certain degree forces applied on persons, or to introduce them through simulation. Once we have these biomechanical loads, then actually we can apply this on an avatar, which in this case we use Bob. And Bob takes in the movement, he takes in the forces applied on him, and then he calculates, okay, what torques should I have on my joints in order to create this movement under this torque. Once he knows which forces you have in your joints, then he can project it also in your muscle groups. And you can have a very detailed analysis of how your muscles are being activated, which forces are in there. Besides that, AugmentX, it's a lab at the University of Brussels, and we also have a second lab in Kortrijk. So it's, we are not selling anything, just the knowledge. So in that sense, we are completely independent. And then besides this, yeah, AugmentX, maybe I touched upon it earlier. It's actually an infrastructure. It's just this laboratory. But I think that it's not enough to just pay money and put the infrastructure there. You also need to have a research mission. You need to have something that you want to find, scientifically speaking. So for me, the research mission was to be able to estimate the performance of these exoskeletons at every workplace. And this is a mission that pushes us forward. I think this is important. You have to be, my parents always told me, be happy with what you have. But it took me a while before I realized be happy with what you have is one thing, but also want a bit more. And I think a research mission is something like that that can propel us a bit forward and make our infrastructure more interconnected and optimize our services. So the other part that AugmentX does is we have this infrastructure to assess. We also have augmentation infrastructure. So we have 20 existing exoskeletons that we have in our portfolio for companies to use. We also have cobots and stuff like that, so we can develop a cobot demonstrator if you have a case where you are not sure, should I pay 60,000 euros to then try to develop a cobot? Maybe it's better to come to our place. We will develop it with our infrastructure. And then if you're interested, well, you get the code, you get the grippers that have maybe been made purposefully for your application, and you just buy the research, but you're sure up front that it's going to work. Okay, so I already touched upon it as well. There are two big legs in AugmentX. We have the infrastructure in Kortrijk, which is in the lab of Flanders Make, and then the infrastructure in Brussels, which is in the lab of the VUB. But for us, there are really three levels of work. We have the clients, so we can go there, do a measurement. We can look at it in Brussels or in Kortrijk, develop maybe a mock-up production line or something like that, and then we can bring it back to the client, demonstrate it, and if necessary, we can loop over this. So industrial services, holistic assessment of labor. So motion, forces, physiological signals. So under that we understand heart rate, sweat, breathing. There are many EMG, so many of those sensors are also incorporated. And yeah, of course, the exploration of exoskeletons and the development and testing of collaborative setups. So these are some examples where we did some demonstrations of exoskeletons. This is at Velo. This is somewhere else, I forgot. This morning I was at Bpost, and this one is at Volvo, at Audi. But here we also do an assessment, so we have the orange boxes, which are basically part of our mobile assessments. So this is a case that we did for Bewell. So here we developed a cobot demonstrator. So as you can see, there is quite a big object attached to the cobot, and we only had 3 points where we could fix the closet, basically. It's a big closet, it's an electrical cabinet, and the idea of this demonstrator is that it represents the closet in different directions, orientations, so that as an operator you just have to do your work, but you don't have to turn around the closet and the whole thing. The other thing that was challenging, as I already said, the closet weighs 16 kilograms approximately, or 15 or something. And so, because we only had 3 points of attachment, 1, 2, and then 3 a bit further, whoa, sorry, it was not so easy, and we used suction cups and electromagnets in this case to make it work. And so in this case, I'm wearing these Xsense, which are IMUs basically. We have 17 IMUs. I'm wearing the Moticon insoles, which are insoles with 17 pressure-sensitive zones. So here you can already see this is the first time that the first development stage, and I'm working. The lights give you cues as to know, like, okay, this is an intermediate phase. It was our first program we ever wrote. When the light is white, you know you have to do some work. When the light is purple, you have to do some work, but also you have to add a weight. If you don't add the weight, then of course the cobot will not know. It will assume that there is extra weight, So if you really have to add the extra weight, because otherwise the piece is going to fall upwards. If it falls upwards, it will stop immediately because it realizes something is wrong. That's a cobot. And it's in the lab because the capture on site didn't work, but we are using actually the mobile assessment equipment. So you can see also we have the forces in the feet. And in that case, we also have like the shear forces in the spine. We can also have compression forces in our spine, some asymmetry angle, and yeah. So these types of analysis we can provide for people. This is about 6 months ago. So in the meantime, we evolved a bit as well. So the next use case, as I said, is the exoskeletons. We have to add them also to our knowledge base. And so we first used the torque characteristics that we could find online. So in this case, it's the mate. I have it with me if people want to try a bit later. So the mate is a shoulder exoskeleton. It gives you support to your shoulder. So for people who work like this a long time or like that overhead a long time. And when you look at the characteristic, you can see that when your arms are completely down, you don't have any support. When your arms are at 90 degrees or when your shoulders are at 90 degrees, you have the full support. And when your arms are completely up, you have zero support again. And this is the first comparison. So here we have two bobs. And we have the torque curve on the red torque curve on the top, which is basically the work if I would do it without an exoskeleton. And the torque curve, the blue one on the top, is the case when we add the exoskeleton. So you can clearly see, okay, there is less torque that the human has to create. And then the two graphs underneath, these are the deltoid muscles. So there is a deltoid that's more on the front and a deltoid that's more on the back. And so the two of them together provide actually this torque or create this torque. And you can clearly see that the beginning is the beginning and the ending is kind of a, there is the bump here in the green and the blue that you can recognize, and the start of the red and the black can also be recognized in these torque curves. We also maybe, I don't know if I can repeat. Yeah, I can repeat. The other thing that you can see, there are two forces basically applied on this arm. So actually one of the forces, the one that points upward, is the force that the exoskeleton applies on the upper arm. And the one that's lower, it's actually a force that's at the same location, but it's actually applied on the scapula, so on the shoulder. And in this way, we can create basically this joint torque on this joint. This is the same stuff, but with an exercise, as you can see, where I'm screwing, so it's a bit more dynamic. At the same time, I was also wearing EMG signals, so anyhow. But when I looked at the EMG, so electromyography, the EMG sensors allow you to look at how you activate your muscles, and you can also deduce how your muscles become tired. But the EMG is a bit sometimes difficult because, like in this case, we do a one take and you have a clear picture. With the EMG, you need to do many takes, which makes it much more cumbersome, much more expensive, much more difficult. So this is kind of a big advantage. This is also a use case. Okay, this torque curve, we sucked it out of our thumb. It's not a real torque curve, but we just wanted to show that we can have a torque curve. We could have different characteristics characterizing an exoskeleton, and we can apply it to, again, our biomechanical analysis. So this is another system. It's not the mobile. Actually, it's a combination. I'm using the Vicon mocap system. These are the cameras that you see on the top, and some force plates. These are the blue tiles. And yeah, here you measure immediately basically the motion of the person. With the orange pieces, it's the same. It's the mobile system, so it's IMU based. It's also very good, but it's a bit less accurate. In this case, we tried also to do a case where we had a very bad calibration. And what happens with IMU systems, if actually on the longer run, in the beginning the measurement is quite good, but on the longer run there is a drift that's created. So if you do a very long measurement, at the end the measurement is not so good. You have to add a real position measurement with a camera or something like that to bring it back to the same position. And this is also what we see in this case. So here I have the two guys who are measured with the optical mocap system, so the Vicon system. We have one guy with an exoskeleton, the back exoskeleton, the PyExo, and we have the other guy here who's actually measured with the XSense system that was not so well calibrated, and you can see that there is kind of he's about almost to attack the other guy. So this is something that you cannot have if you measure the position immediately, and so yeah. But again. It's a very convenient way to do our analysis. The forces in the hands, I have to simulate them, so I have to add them in, and yeah, there are many things that we can say. This was 11:01, so basically about 2 weeks ago. This is when we opened our lab, and there I did a live demo, a live capture, and so this is me doing some work, and then this is Mo. So this is the first avatar from XSense. So this is the mobile system. This is a better capture, and here the quality is already much better. And then from Mo, we basically, I'm also measuring the ground reaction forces, which you don't see here. But then afterwards, we bring it into Bob, our second avatar, and there we can introduce the force measurements that we also added. And then in Bob, we can do a bunch of biomechanical analysis, like in this case also a REBA analysis, but much, much more. And most importantly, I think the compression forces in your spine and the shear forces. I think I will show this as well in a bit later, or maybe not. Maybe not. But so yeah, I think that's gonna be about it. Research services. So our biggest client is of course VUB, and for the VUB, well, we are an interesting partner for them because there are many research projects that use the human-machine interaction. Me myself, I work for Robotics, so this is really focused on human-robot interaction, and so having the capability to assess human and cognitive stress. Cognitive stress, I put it here as well because we venture into it, but I wouldn't say it's an industrial service that's ready-made to go in a company. Research in exoskeletons, obviously, because we have the big collection. The development of cobalt demonstrators is also very useful for them. And then this is something that I didn't talk so much about, but we have a big bunch, or we have a big set of sensors, and synchronizing these sensors is a very important thing to be able to provide our services in a meaningful way. So we really specialize in this last part. So these are some research projects. So this is a person who came with a TOBI to do cognitive assessment. So the TOBI tracker that tracks how your eyes are looking, are you attentive or not? And also he had an EEG. We integrate his stuff on our system. We have another researcher here who was very happy, clearly, who did some measurements about the stiffness between a customized cuff. This is a customized cuff, and a more generic cuff. So we added a load cycle on the cobot. We said, okay, do some oscillations up, down, left, right, and we see how the cuff is moving compared to the leg. And then, other projects. This is not completely ready yet, but it's our setup that we want to use to measure our own torque curves of the lower back exoskeletons. And in addition to just measuring the torque, it actually measures all the forces in the sagittal plane. So we can measure the torque on each piece. We can also measure the X force, the Y force on each of these pieces. So there are 25 load cells in it, and it will allow us to have a much better characteristics of these exoskeletons. Then also some research projects with the German Bionics and some other stuff. So these are just some pictures of the tooling that we have. This can also be useful if you prepare the cobot, but you want to test it on impacts. Then we have impact testers that are according to a certain standard. I'm not a specialist on that, but just a bunch of these are just some of the things, and then some of the exoskeletons that we have for companies to test out. So there is There is an active also German bionics for the lower back. We also have an active for the shoulders, the Festool. Interesting also to know is that sometimes people ask me, but yeah, but you don't see it yet in companies. Is it really something? And to this, I stress also that the German bionics, so the red one, that one, we bought it 2 years ago. It was one of the first exos we were able to buy. We bought it for 24K, and it was refurbished. So at that time, it was 40K. The Exo Festool, we bought it last month. It was 3.5K. So you see how the prices are coming down. And also at the same time, the technology is getting better. And then these are some, the lab in Kortrijk is a bit more industrial than the lab in Brussels. So here we can also help simulate industrial use cases with smart handlers, for instance, to carry heavier loads. And there are also some flexible assembly tables with robots. There is just one for now, but I think at this stage there are already more robots. And with, there are like automated cars going in between them. And yeah, this is the smart agile assembly lab, which is basically a huge structure. And on this you have an XY positioning system, and you can have an arcade system that's hanging on it. So in that case, you can actually track what the operator is doing, and at the same time project instructions. So these are also facilities we have available for companies to develop, for instance, a better set of instructions, digital instructions, to, in that case, help with the cognitive load of the work. So yeah, this is the mobile assessment tools that we have, some of them, with the Xsense, which is very nice. We also have finger tracking since last month. We have 4 of those. We can actually measure 4 persons at one time and put them in one scene. We only have 1 pair of hands, unfortunately. Some other, like the Kinect, and this is another similar system. It's the Thea Ergo. Kind of does the same stuff with some extra quirks and features. These are the insoles that we use, the Moticon Open Goes. So they have 17 pressure-sensitive zones and an IMU also incorporated in them. We are also developing now, there is a research project going on to help us estimate the shear forces as well. But anyhow, so some nice developments that are taking place. The ergo FET that we can use to push or pull a chariot and also bring it into our measurements. And then some more of the physiological sensors that we have. So the Cometa is an EMG device. It measures muscle activation. It can also give you information on how tired the muscle is. This is just a smart watch, actually, that brings already like oxygen saturation level and stuff like that, also heart rate. And then the Equivital, it can measure heart rate, breathing. So it looks at how large your cavity is, your chest is. But also sweat, and there is also an IMU in it. And then the VO2 master that can also look at your breathing rates. And we measure all this synchronized with a framework we developed ourselves when it's necessary. And these are just some specifics of the laboratory that we have of the Vicon and the Kistler force plates. So this is really a top-of-the-line system. The price was, I would never be able to pay it. It was it's 10K a camera, and we have 30 cameras. We got a good price, of course. We got a good discount, but these are systems that are not cheap and so available to be used. I think that's about it. So if there are any questions, feel free to ask. Thank you.